crib, I wanted to go over the last portion of the notes because we didn't get a whole lot of time in class. So you need to pull up your notes, or you need to pull out a sheet of paper to use with your notes and look at your targets. We're just going to review Lewis dot structures for single atoms and also the ionized atoms. Here we have sodium, magnesium, and chlorine. Sodium, magnesium, and chlorine, and it shows you the Lewis dot structure for the neutral atoms. Remember that in a neutral atom, the proton count is equal to the electron count. Okay, so when you look at the periodic chart, you can determine how many electrons they would have. I'm going to pull up an interactive periodic chart here. So, for instance, there's sulfur. Notice how it's right here. I'm showing it, and then it's really just difficult for me to look in both places. But you can see sulfur right here, and sulfur is element number 16. Element 16, it's in this group, which you didn't have. This one doesn't have the group numbers in front of it, but this is group 16 as well, because that's 17 and that's 18. Oh, there it is. There's group number right there at the top. You see the group number? So that means it has 6 valence electrons and 16 protons and 16 total electrons. So 16, or 6A, has 6 valence electrons. And I go back to Zernal. So if I write sulfur, I write the symbol S, the 6 valence electrons, 1, 2, 3, 4, 5, and 6. And so sulfur here has 6 valence electrons, but how many total electrons rather did it have? Well, the atomic number is 16, so it has 16 protons, and it would also have 16 electrons. So it has 16 protons and 16 total electrons. 6 valence electrons, 16 protons, 16 total electrons. When you're doing the dots, I normally just stop at the top, start at the top and go around, but I will take it in pretty much any form. However, the maximum number of electrons in the north, the south, the east, and the west will be 2 electrons, and you'll need to keep that in mind as we move forward. Now we're going to look for boron. The symbol for boron is a B. Go back to the periodic chart and look at that. Find it. There's boron. It's element number 5. It's in column 13, which are group 13 or 3A. Group 13 or 3A has 3 valence electrons. It has 5 as the proton, the number right there. 5 is the atomic number, which is the number of protons. So we go back over here and write the 3 valence electrons, 1, 2, 3. So it has 3 valence electrons, and it has 5 protons and 5 total electrons for the neutral atom. And then we go down to ions, and this is kind of where I had to hurry. Atoms that have gained or lost electrons are ions. They have been ionized. We have anions and cations, and I usually write anions as a negative ion. A negative ion. It has a negative charge. And then anions have more electrons than protons. And then cations, I usually write like this, with a humongous positive sign right in the middle of it. And that means it has more positives than negatives. So it has more protons than electrons. So add that part into your notes. And we're going to now talk about these. Now, we have the neutral atom of chlorine written right here. That's neutral. Now, if you look at chlorine on the periodic chart, again, there's chlorine. It's in column 17. Okay, those are the halogens. Column 17, it has 17 protons and 17 electrons. So I'm going to go ahead and draw the Bohr model of chlorine over here. So chlorine, I'm just going to draw the nucleus with it has 17 protons in there, but 17 electrons. The first 2 electrons are in energy level 1. That would be in the 1s level. Then we have 8 electrons in the second energy level. That's the second energy level. And that second energy level would include the 2s and the 2p. And so if I look at the periodic chart again, here's energy level 2. And there's the 2, the S block, 1, 2, and go straight across. The 2, energy level 2, the P block, 1, 2, 3, 4, 5, 6. So it has all that. And then we have to keep going. Now we have the energy level 3, and it has the S block, 1, 2, and energy level 3P, 1, 2, 3, 4, 5. So 2 plus 5 is 7 electrons in the energy level 3. So I'm going to draw those. 1, 2, 3, 4, 5, 6, and 7. And it has like a space for an extra electron there. I'm going to go ahead and erase this right there and put these lines. But no, the second energy level here is where this is the second energy level. The second energy level includes the 2s and the 2p. And the third energy level that we have here has the 3s and the 3p. Okay? Now, there's something called the octet rule. And we haven't talked about it a lot yet, but it is important for what's going on here. The octet rule, oct means 8, like an octopus. So oct, 8. It basically means that the atoms are happiest when they have 8 electrons in the outer shell, the valence shell, because valence electrons are on the outside. These are the valence electrons for chlorine, right here. 2, 4, 6, 7. We have one empty spot. Chlorine will be very happy if it can get that last electron there. That's the 8th electron. So if another electron comes and fills up that spot, we will now have 8 valence electrons. So the neutral atom of chlorine had, let's look again at the periodic chart. There's chlorine. It had 17 protons and 17 electrons. So the neutral atom of chlorine had 17 protons and 17 electrons. That's a plus 17 and a minus 17. Oops, not 18, 17. Okay, there, erase, put the 17 there. Minus 17. When I add that together, I got 0. That's for the neutral atom. But now, if I add an extra electron in there, I have plus 17 and minus 18 because I added one more electron. This is neutral, but this is when I added the extra electron in. We went from 17 electrons to 18 electrons. So now if I add a positive 17 and a minus 18, I get a minus 1 charge. So this is the anion of chlorine. And I draw it with chlorine. I put 1, 2, 3, 4, 5, 6, 7. That's how many electrons I had there before. I like to draw an E for the one we just added, just to show it. We added an extra electron. We have to put brackets around it now because it added that electron and it has a minus 1 charge, so you put a negative symbol on the outside, or a negative 1, or a 1 minus. I will take all of those to show that the whole thing now has a negative 1 charge. It's no longer neutral. Now what about magnesium? Let's go look at the periodic chart and see magnesium. So there's magnesium. It's element number 12. Notice it's in energy level 3. It goes up to 3s2. It fills up energy level 1 and energy level 2. It's at energy level 3. So I'm going to draw that one. And it has 12 electrons around it. The first 2 electrons are in energy level 1. And then we have 8 electrons in energy level 2. So that's energy level 1, that's energy level 2. Energy level 2 includes the 2s and the 2p. And then we have just 2 electrons in energy level 3. Okay, if I go back to the periodic chart, you can see that. There's energy level 3. This is the S block right here. 3s1, 3s2, 3s2. And I don't think I have the electron configuration showing up on here, but that's fine. So 3s2. All right, now remember we want to have 8. We want to have the octet rule, 8 electrons in the valence shell, the outer shell. These are the electrons. This is one I'm circling in red, are the outer shell for magnesium. Well, that's only 2. So it either needs to go find 6 or lose 2. Well, it's easier to lose 2 than it is to find 6. If I remove these 2 electrons from the atom, it goes down to this lower level right here where there's 2, 4, 6, 8 electrons, and it makes the molecule happy. So we're going to lose those 2 electrons. We can just erase it. What happens is we end up with magnesium with 2 electrons in the first energy level and 8 electrons in the second energy level. And we lost the third energy level. Okay, so if we lose 2 electrons, that's saying we subtract a -2 charge, we end up with a +2 charge. And so the way you write magnesium now, the cation ion with the positive charge is magnesium with the brackets and a +2 charge on the outside of the brackets. That's how we get the cation ion. So let's see right here, we removed it. These go away. They actually get sent to somebody else, another atom that might need them. We'll take those 2 electrons. We lose the entire energy level so that the new cation ion, this is the cation ion right here, has lost electrons. Before we had 12 protons and 12 electrons. And we add that, that's equal to a +12 and a -12, that's 0. But when we lose 2 electrons, we go down, now we have 12 protons and only 10 electrons. Now we have a +2 charge. You can only lose electrons, you can't lose protons. Remember that. You can gain or lose electrons. The proton count stays the same because the protons define what the atom is. Okay, that's what the ions are. I hope that helps.